Well, hello and welcome. In this presentation, we will be looking at the application of recurrence relations to work through problems associated with flat rate depreciation. In summary, flat rate depreciation is effectively the linear depreciation that an item will experience over its lifetime. In other words, it will depreciate at the same amount of dollars each year. Now, flat rate depreciation can be modelled using the following recurrence rule. Vn equals V0, in other words, the purchase price, minus ND, where N typically will be the number of years. So, just as a recap, linear decay is the sequence. We start at an initial value, in this case 201, and we will decrease our value by the same amount each time. That's the rule. In this case, D will be -3. We are decreasing by 3 units each year, each month, each quarter, each whatever. And we can say the recurrence relation, the value of my next term equals the value of my current term minus 3. So the recurrence rule would be V0 or Vn equals V0 minus ND. In other words, the value of my nth term would be 201 minus 3 times whatever that value of n happens to be. So let's look at an example. A stapler, a $201 stapler depreciates at a rate of $3 every day. How many days does it take for the stapler to depreciate to a scrap value of 0? Now, scrap value basically means you may as well start to think about getting rid of that item because it's no longer worth any money. So, here is the sequence. Start at $201 and I will go down by $3 every single day, and I really want to know how many days until I get to 0. So my initial value 201, my value of D -3, and what I need to do is come up with the recurrence rule. So Vn equals V0 minus N times the D. So I want to know how long it will take until my stapler is worth 0. It will equal 201 minus 3 times N. I just need to use a little bit of basic algebra here to solve this equation. I could either use the solve function on my calculator or quickly just do this in my head. So really what I'm trying to solve is 0 equals 201 minus 3n. So, in other words, if I subtract 201 from both sides, and that's 201, so I'm trying to solve -201 equals -3n, and all I need to do is divide both sides by -3 and divide this side by -3, and 3 will end up with being 67. So I could say that n will be equal to 67 and my unit will be days. So there you have it. That's the first example of a couple that I'll be going through. So I'll just move on to the next one. Yeah. Okay, I purchased a bike for $2,000 and it depreciates at 5% of its purchase price every year. What is the value of the bike in 6 years' time? We're not given a value of scrap, so we'll just assume that the scrap value is 0. So what I need to do is just think about in the back of my mind the recurrence sequence and the recurrence rule. So, whoops, just didn't really want to drag that out there. So, my initial value, well, what did I purchase the bike at? $2,000, and it's going to depreciate at a value, well, it's going to go down in value by a value of $100 every year. Now, you might be saying, how did I calculate that $100? Well, it's 5% of 2,000 is $100. In other words, we're depreciating it at 5% per annum of its purchase price, and the purchase price was $2,000. So, effectively, my value of the bike after 6 years will be the initial value of 2,000 take away, or subtracting, 6 times 100. Well, this is 6 years, $100 per year. I end up with $1,400. Let's move on to the next question. Now, here we go. A $120,000 photocopier is expected to have a life of 6 years, after which it will be sold for scrap. And I've given you a value of $15,000. Now, if the copier experiences flat rate depreciation, what is its value after 5 years? So, in other words, we know that we're going to have an initial value of $120,000, and it's going to keep going down in value by the same amount because it's flat rate depreciation, and we want to keep going until we get to about 15,000. Once we get to 15,000, that's pretty much where we'll stop. Now, what I need to do is work out how many years, well, basically how much will my copier depreciate every year. Well, I have actually done a calculation here of it's going to decrease in value by 17,500. You might ask yourself, where does that figure come from? Well, here we go. It's worth, or it cost, $120,000. When I sell it for scrap, I will recover $15,000. So you could say that this copier over 6 years has cost me $185,000, which is equivalent to $17,500 every year. So just need to plug this into the recurrence rule. I want to work out the value after 5 years. It will be my initial value minus 5 times how much it depreciates every year. So there you have it. I hope this presentation has given you a better understanding of the recurrence relationships and how recurrence rules can be applied to solve problems associated with flat rate depreciation. So until next time, good maths and bye for now.